April 2022. Question number 3C. Chi-square tests. Chi-square tests. So nasoma hivi. A certain new strategy K was claimed to be effective for teams playing a certain game. In marathon of 400 games, half of the teams used strategy K and the other half used strategy P. The team's performance was recorded in the following table, given that. Now, on the basis of the above data and using the chi-square method, advise whether there is a significant difference in the effect of the two strategies. So when you're doing chi-square, the first thing is called hypothesis. Hypothesis. Now, in the hypothesis, H naught, we normally say there is some association or some correlation. That is how it is stated. There is some association. You can finish in terms of what is it you are comparing, or you can leave it that way. Like now, hapa tunaweza sema between strategy K and P. Ama uiache hivyo. Ukiacha hivyo, that is now a general. Anytime you have a chi-square, inakaa hivyo. Then in the alternative, we say there is no association. There is no association. From there, as you know, we go to the second step, which is called significance level. Significance level. Now, significance level, we have alpha at 0.05. Then we go now to test statistic. Test statistic. Now in test statistic, chi-square is given as sum of F naught minus Fe squared, which is divided by Fe. That is how we get the chi-square. So what we do from there now, we draw the table, which will show us what we call observed frequencies. Observed frequencies. And these observed frequencies, they are the ones that we are calling F naught. F naught. So this F naught K here, we have P and we have total. We have those who won here. We have those who are defeated. We have those who drew. And we have total. 130. This is 110. So this is 240. This is 20. This is 30. This is 50. 60. 50. 110. This is 210. This is 190. And that is 400. Then from there, we prepare another table. Get what we call expected frequencies. Expected frequency. Frequency or frequencies. FE. And this one is given as row total multiplied by column total. You divide by grad total. Row total multiplied by column total, you divide by grad total. So we have K here, we have P, and we have total. So I think we shall be dividing the columns as we do the workings. Like now for the first one here, this is how it will be. Kuja hapa, naangalia the root total. The root total is 210. Una multiply na the column total, which is 240. Divide by the grad total, 400. $126. So that goes to the same thing here. When you come to this one, the row total is 190. Column total is 240. Divide by 400. Now, as you do that, you must ensure that they will add back to this 240. So that's all. Yeah. So in case there are roundings, you must ensure they add back to this 240. All right, to the quantitative. Defeated, we also argue likewise. So So when you get here, the row total is 210 and the column is 50 divided by 400. $26.25, so you can just make it 26. Then here we have the row total 190, column total is 50, divide by 400. So we can make it 24. So that the yard back to what? 50. Yard back to 50. Then those who drew we get the row total is 210 and 110 divided by 400. You can make it 58. Then 190 times 110. So you can make it 52, right? And it adds back to 110. So total to 10 and 190, yeah? So that the grand total is 400. Now from there, you may require analysis table. Analysis table. The analysis table, we have the F naught, then we have the FE, then we have F naught minus FE. You square it, then you divide by FE. The difference you square. So we have 130, we have 20, we have 60, we have 110, we have 30, we have 50, it is 400. We have 126, we have 26, 58, 114, 24, 52, and 400. So get those values and give me the total down there. What is the total? 3 points. 3.3. Patience, are you getting the same? Something close to that?
Yes.
Good.
Yes.
So down there now you tell us chi-square calculated is 3.3. That's how you get the chi-square calculated. The next step is known as decision rule. Now, in this decision rule, first of all, we get the degrees of freedom as row minus 1 times column minus 1. So, unarudi kwa hii table tumekuwa nazo. They have 2 rows. So this is 2 minus 1. And the columns are 3. There is 1, 2, 3. So 3 minus 1. So this is 1 times 2. That is 2. Those are the degrees of freedom. Alpha, we already know it is 0.05. So now take your tables. Take your tables and tell me the chi-square critical at 0.05 and 2 degrees of freedom. It should be almost the very last table. So Taisoma from the left, that's where we have this specific set. After Malik at 0.05. Have you seen it? And then you go to row number 2, where we have 2 degrees. Read for me what is there. 5.99. 5.99. So with 5.99 there, with 5.99 as the critical, you proceed to the next step, which we call conclusion. Now, conclusion will simply tell us whether we are accepting or rejecting. So now that the calculated is less, we always say accept. So accept null hypothesis since the chi-square calculated is less than chi-square critical. That is 3.3 is below 5.99. So we are going to accept. And what does that mean? The meaning of that is now that we have accepted, it was saying there is some association. So you say meaning there is some association. Now we can complete some association between strategies P and K, between P and K. There is some association between strategies P and K. Good. So that is all about chi-square. I don't know whether you need another one. That is good enough. What do you think? Iko sawa, eh? Okay, so kama iko sawa,
The significant level inatonga
you can change, eh? But for CPA naonanga wakileta tu hiyo. Yeah, it's the most common. It's the most common. It has to go with what I told you, that generally people break relationships not because of very big or very many bad things, but like a very small thing. Yeah, umekuwa na mtu for wrong, but this small one thing kamaleta maneno mingi, so like a 5%. Yeah. Okay. So then we can start with question 1 of the same paper. We can revise question 1 of the same paper. So in question 1, we are told I'm wondering whether I revise the same questions because they are already somewhere recorded. Whether I can send you that recording with you other questions. Yeah, because now you see we are only going to revise for today and Friday. So I'll send you the recording, which I think has question 1, question 2, question 3, I think even up to question 5. Up to question 5. So let's go to the paper of December 2021. Paper of December 2021. Paper of December 2021. Now in that paper, question number 1, we are told to explain the following terms as they are used in time series. As used in time series. Cyclical variations, random variations, seasonal variations, and the trend. I believe those are in your notes. You know, cyclical is the one that takes a long period, like 14 years. Random is the one that you cannot predict. Seasonal repeats at least once every 1 year. And the trend is a consistent change. Now, part B, the following data lists the profits reported by XYZ in each of the following months. So we are told to estimate the trend line using the ordinary least squares method. So if you are using the ordinary least squares method, so the trend line using ordinary least squares method, So the format is always y is equals to a plus b x. That is the format. Where we normally say that b is n sum of xy minus sum of x sum of y. You divide this by n sum of xy minus sum of x, you square that. And then a is sum of y minus b sum of x, divide by n. So here we have prepared the analysis table. The analysis table, we have the month. This month, we have the number. That number will become our X. We have the profit. That profit will become our Y. Then we require a place where X is multiplied by Y. And we require a place where X is squared. So we have January, February, March, April, May, June, July, August, September, October, November, December, and the total. And the total down there. So this is number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I told you when you are dealing with a time series, you just number those periods. You number the periods. So then you have 40 here, 38, 39, 41, 36, 41, 34, 37, 35, 37, 40, and 41. So work out, get the totals, and give me the value of B, and you give me the value of A. From where I stand. Unapata 0.07 and A negative.
No, B
B is negative. Then 38.705. So if that is okay, then y is equals to 38.705 minus 0.07x. So the question is asking us now, estimate the profit reported in March 2021. So March 2021, X will be equal to, you see now, this was number 12, which was December 2021. So January will be 13, February will be 14, and March will be 15. So the Y predicted will be 38.705 minus 0.07 times 15. 37.6 655. Good. Question 2. The advantages of the arithmetic mean. Those ones are also in your notes of descriptive statistics. Yeah. The following data shows the distribution of profits of 150 manufacturing companies in a given year. So we are given that. We are told to get those items. As I told you, you always begin by noting the type of data. Now this data is grouped. This data is grouped. We're dealing with group data And in the dealing with group data, the first thing they're asking us is to get the arithmetic mean. So arithmetic mean x bar is given as sum of fx, you divide by sum of f. They're also asking us to get the standard deviation. So the standard deviation is sum of fx, which is squared, you divide by sum of f. Then you minus sum of fx, you divide by sum of f. This one you square, and then you get the square root. And then they also want CV, so this will be standard deviation. You divide by the mean times 100. Times 100. So sasa we make our analysis table. We make the analysis table after knowing which formulas are required. And here we will have the profit. Then we will have the midpoint, which will become our X. Then we will have the companies, which becomes our F. Then according to our formulas, we will need a column where F is multiplied by X. We also need a column where F is multiplied by X squared. Those are the columns that will be required. So we have 10 to 20. We have 20, 30, 40, 50, 60, 70, 80, 90. So the midpoint, you remember maybe I record the company's first, that is 15, 13, 25, 30, 16, 10, 22, 12, and 7. So you just add the two limits, you divide by 2. So this will be 15, then 25, 35. So fill in those columns. And get those values. You're through? What is the mean? 15? 50.93. Standard deviation. Have you got this part?
22.81.
2.81. And CV.
44.79%.
44.79%. Good. So if we are in agreement, we go to question 3. That says, explain the following terms as they are used in Markov. One is a Markov process. That one we know is a probabilistic process that is used to study the changes from one state to another. Equilibrium, we know, is where there is no further change. The current state is equal to the future state. Absorbing state, we know, is where you can join freely, but once inside, you can never quit. A closed state is a state where no new member can join, and those who are already there, none can exit. All those things are in your notes. So we go to part B that says, the marketing department of Jacuz Limited estimates the daily demand function of one of its products to be linear in nature. If the price was fixed at shillings 570, the daily demand would be 400 units. If the price was increased to 820, the daily sales would drop to 200 units. The production department has indicated that the marginal cost of producing Q units of the product is given by the following equation. So we are given that the daily fixed cost is that. So they are now asking us to get the revenue function and the others. So the first thing there is to come up with the demand function. Demand function. Now, demand function is the one that says price is equal to A minus BQ. It's the one that shows the relationship between price and units. So we are told at the price of 570, the units that are demanded are 400. So 400B. That is equation number 1. But if you increase the price to 820, demand goes down by half to 200. So I want you to solve those two equations and tell me the value of B and the value of A. Solve the two equations on your own. Tell me the value of B and the value of A. Not yet. B is 1.25. A 1070. Patience, are you agreeing?
Yes, I do.
Good. So B is 1070 minus 1.25 Q. So that is the price. Ukishapata hiyo, now you proceed to revenue function. Revenue function. Now revenue should be the price you multiply by the units. The price you multiply by the units. So our revenue should be 1070 Q minus 1.25 Q squared. Total cost function. Total cost function. You will get it by integrating 2Q minus 570 with respect to Q. So this becomes 2Q raised by 1. You add back 1. You divide by 1 plus 1. You minus 570Q, currently raised by 0. You add back 1. Then 0 plus 1. And then you add the constant of integration. So this proceeds to become TC is equals to Q squared minus 570Q plus C. C, I told you, is the fixed cost. When you're dealing with the integration of the costs, it's the fixed cost of 1100. Yeah. So total profit function. Total profit function is that profit is revenue, which is 1070Q minus 1.25 Q squared. You minus Q squared minus 570Q plus 1100. So this pi is 1070Q minus 1.25 Q squared minus Q squared plus 570Q minus 1100. So putting like terms together, these 1070 to join these 570, we get 1640. That's all. Then these two to join so that you are left 2.25 Q squared minus 1100. So when you see that, you then proceed and tell us if we are looking for maximum profit. If you are looking for maximum profit, the differential of pi with respect to Q should always be 0. That is, when you differentiate this, you'll get 1640 minus 4.5 cubed is 0. So Q will be what?
Three 64.44.
144. So we can make it 365 units. So profit then will be equal to 1640 times 365 minus 2.25 times 365 squared minus 1100. Hmm?
297,743.7.
297. 7. 5. Good. So question number 4 says, in the context of hypothesis testing, distinguish between type 1 and type 2 errors. Those ones you also know. Type 1 is when you reject a true hypothesis. Type 1 is when you reject a true hypothesis. Someone telling you something that is very true, but you think they are right. Type 2 is when you accept a false hypothesis. It's when you accept a false hypothesis. Someone telling you something which they know is not true, but for you, you believe that is true and you act on that basis. The sales before and after a promotional campaign in 10 different regions for a certain commodity were recorded as follows. So we are given that. Using a 5% level of significance, determine whether the promotion campaign was a success or not. So that requires that we do a hypothesis test. question belongs to sampling theory, significance tests. And as you can see, this is a case of unknown population. Unknown population. And with unknown population, we are told to check whether there is a difference. So it's a case of means difference. It's a case of means difference. It's a case of means difference. So we need to compare the two means which are not provided. So we shall require to have a table. We shall require to have a table. And because we know what will be contained, one, we know we will need to get the mean. And because this data is ungrouped, the mean is given as sum of x, you divide by n. We will also require to get s somewhere. And we know that s is normally given as x minus x bar. You square this. That is the sum. You divide by n. You get the square root after you have squared. So we will then require to do an analysis table which can help us compute those values. We can have the region, although not a must. The region. So before campaign, now before campaign, we have the values of x, and then we will need x minus x bar squared. Then after campaign, maybe this one we can call it x1, and this one we also call it x bar 1, because those are the values we shall take to the table. Then here we have x2, and then we have, so this one I should also say x1 there. So x2 here minus x bar 2 squared. So region 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we'll have the totals. So this is 53, 28, that 1, 48, 50, 42, 63, 40, 25, and 30. Maybe we can first of all deal with the one so that you're able to complete the other one on your own. Give me the total of 410. So it's 410 down there. Now you come and tell us x bar 1 will be 410 divided by 10, which is 41. So to answer kujaza hapa 53 minus 41, that is 12. Eh? You square 144. 13, 169. 10, 100. Eh? 7, 49. 9, 81. 1, 1. 22. Forward. 4, 8, 4. 2. No. 1. So it's 1. 16. 2, 5, 6. 11. 121. So add those totals, those values. Hmm?
1406.
410.06. So our S will be 410.06. Huh?
1406. Okay. See 14.
Oh, just 10. So it is 1406. 1406. So that 1406 you divide by 10, get the square root. 11.86. So you can do the same. So this is S2 or S1. This is S1. So on your own, do the same and give me X bar 2 and S2. Then we shall pick up from there in the next lesson. Thank you so much.